Welcome to Simplifying Rational Expressions. So we're going to go back to I'm going to say grade 9, and look at one way to simplify fractions that will help us when we get into these rational ones. So if we were going to simplify 5 over 15, the way that we're going to have to do with these rational expressions, we would break it down into, of course, 5 is prime, and 5 times 3. And then because 5 divided by 5 is 1, we'd be left with 1/3. So sliding across here I've broken 30 over 18 down into the product of its prime factors. So we have 2 divided by 2, 3 divided by 3, and what's left? 5 over 3. So now what we'll do is we'll look at expressions and we'll see how they simplify. So remember, if our numerator and denominator are the same, and we can always figure this out by substitution, right? So if x has to be the same for each, so let's say x was 2. Well, 2 plus 4 is 6, divided by 2 plus 4, which is 6, right? So here, right, we have an expression equivalent to 1. Now, we know when we add, order doesn't matter, right? So it doesn't matter, let's say n is 1, we're still going to end up with 3 over 3. So there's another example of expressions that are equivalent to 1. We'll keep going. Same thing. Let's say x is 4. 4 minus 3 is 1 over 4 minus 3. And once again, we have another expression equivalent to 1. So continuing on here, let's put in 2 in place of m. So if you're ever unsure as to whether a set of expressions simplify, take a value and see if it works. 2 minus 5, right, that's going to be -3, and 5 minus 2 is 3. So now we have -3 divided by 3, and that simplifies to -1. So of course when we subtract, order matters, but these will simplify to -1. And here, x plus 6, x minus 6, I'm going to pick 2, right? So 2 plus 6 is 8 divided by 2 minus 6. 8 divided by -4 doesn't give us 1 or -1, and so we have to remember that we have to leave this exactly as it is, because that's where it stays, right? And I'd say that a common mistake would be to look at this and say, oh, n divided by n is 1, but don't forget this n goes with the 7. So if we were to put 3 in place of that, right, 3 plus 7 is 10 divided by 3 is not equivalent to 7. So this one stays the same. So when we simplify these, we always have to include non-permissible values, but from this point on, we will not show all of the steps. And it's very important to remember to always state the NPVs before we simplify, because if we don't do that, we'll lose information. So here's some expressions that are already factored for you. So what we want to do is we want to look for identical expressions in the numerator and the denominator. So of course that divided by that, right, is 1. And we write what's left, okay? And then our NPVs will be x can't be -5 or -1. I'm going to do my NPVs here first, right? N can't be 1 or 3 over 2. And so what am I doing here? I'm just going n minus 1 is not equal to 0 and solving. 2n minus 3 is not equal to 0 and solving. And then what do we have here? So same. And we write what's left. So we'll move over to this one, right? So here we have m squared divided by m. So we have one of them, right? Because when we divide powers with the same base, we subtract the exponents. You can do that too. So, but here we have, right, our opposite. So this and that simplifies to a -1, and we're left with -m plus 2 over m plus 3. So now when we get into these ones, the instructions are step number 1, factor numerator and denominator. Then identify your NPVs, cancel out expressions in the numerator and denominator that are equivalent to 1 or -1, and rewrite any remaining expressions. So we're back to factoring. M minus 6m plus 2. And the nice thing about this is that chances are, right, to help you with your factoring, you're going to end up doing some simplifying, so your odds are fairly likely that this expression, right, will be there. NPVs, just 1, right? M is not equal to -2. And then what are we left with? M minus 6. And I think I'll just move down so that I don't have to slide the paper over. Greatest common factor, 2x, x minus 5. 4x, x plus 5. So we have to really be careful. Anytime we have that variable by itself, the 4 is never going to be 0, right? So we don't have to worry about that, but we do have to worry about this one. So for our NPVs, anytime we have a variable by itself in the denominator, right, x can't be 0 or -5. And order with NPVs doesn't matter at all. So the only thing we can write, we can cancel the x's, and of course 2 divided by 4 is 1/2, and we're left with x minus 5 over 2x plus 5. Just a few more here. GCF. We've got a difficult trinomial here. Forgot about my NPVs. And cannot be. Well, why did I get the n from? X can't be 2 or -5 over 2. And we're left with 3 over 2x plus 5. Difference of squares up top here. NPVs. N can't be -1 or -2. And we're left with that. And then the last one, 2. And this is a difficult trinomial here. This one's going to take another step. You can do it in 1 step if you want. I just did it in 2. Forgot the NPVs again. And then, as you can tell, it doesn't really matter. As long as you go back and make sure you do it here, then we're okay. Y can't be -3 or -1/3. And that's it.